This is the homework for Module 4, Lessons 13 through 23. It's to be found on OnCourse. I'm going to go over the answers with you. If we look at this first problem, it says, which of the following would be a solution for the two linear equations graphed below? We already understand that when we're talking about a solution, we're talking about where two lines intersect. These two lines are parallel. They will never intersect. Hence, there is no solution. Problem 2, which of the following would be the solution for the two linear equations graphed here? This is where they intersect, this point right here. That point is at 1, 2. Remember, this is your x, that's your y. It's at 1, 2. So here's your answer, 1, 2. The third question, what's the solution to the system of equations? Again, it's where the two lines intersect. We can simply read these off the graph. Remember, there's multiple ways of finding the solution to a system of linear equations. You can find it by graphing them and looking for where they intersect. You can find it using substitution. We're going to use both of those in here. There's another one that's called finding it using elimination. We're going to deal with that next week. Okay? So what's the solution for this one? This is at point 1, 5. Your solution is the point 1, 5. Solution is where both lines intersect. It is the one point that is on both these lines. On this, it asks us which set of equations intersect at 2, -1. Well, we talked about if they intersect at 2, -1, that is the solution for that system of equations. Where you see the bracket here, this tells you this is a system of equations. This is another system, third system, a fourth system. So we are talking about two lines that would intersect here at the point 2, -1. What we need to see is which lines would intersect there. Now, there's a couple of ways you could do this. You could use substitution, which means that I could plug this 3 plus x in for this y. Let's try this first one using substitution. If I've got y is equal to 3 plus x, and y is equal to -x plus 1, I can plug this y in here, okay? And that would say 3 plus x is equal to -x plus 1. And I could solve here for x. Say I'm looking for x on this system of equations. If I do that, I could add x to both sides. I've got 3 plus 2x equals 1. I can subtract 3 from each side. I've got 2x is equal to -2. Divide both sides by 2. And x is equal to -1. Okay? We know it's not this one because the x is not -1. And you could go down and you could do this to every one of these equations and see which ones worked. Another way to do this, the way that I find to be simpler, is to simply recognize that we're trying to find two equations that this 2, -1 fits in. All right? Let's see if it fits in both of these. Let's see if it fits on both those lines. Let's just plug it in. Here's your x, here's your y. If I've got y is equal to 3 plus x, our y is -1. Let's see if this is a solution. Let's see if it fits. Our x is 2. That's 3 plus, oops, that was x. 3 plus 2 is -1 equal to 5. No, it's not. So it doesn't fit on this line right here. It can't be it can't be the point where these two lines intersect if it doesn't fit on one of the lines. Let's try another one. Y is equal to 3x. Let's plug in our x and our y. Is -1 equal to 3 times 2? Is -1 equal to 6? No, it's not. So it doesn't fit on this equation, so it can't be where the two lines intersect. Let's try the next one. Y. Our y was -1. Our x is 2. Is -1 equal to 2 times 2 minus 5? Is -1 equal to 4 minus 5? Is -1 equal to -1? It is, so it works on this one. Now let's see if it fits in this one, because for it to be where the two lines intersect, it's got to be on both lines. Let's see if it's a solution for this one. Our y, we're checking, what are we checking? We're checking 2, -1, okay? Let's see if those fit in on this equation. Y is equal to 1 minus x. Is -1 equal to 1 minus 2? Is -1 equal to -1? It is. So it fits on both of these. This is the system of equations for which 2, -1 is a solution. These are the two lines that intersect at 2, -1. And we know that because they are solutions for each of these equations. If I plug them in, the two sides are equal. What's the solution to this system? Remember, if we're doing this graphically, we find where the two lines intersect. That is the solution. That is at 1, 6. So your solution's at 1, 6. Now, the x-coordinate of the intersection of the graphs of the system of equations shown below is 3. All that tells me is that x is equal to 3, right? The x is equal to 3. If I'm looking for where these two graphs intersect, it's at 3 something, right? They want to know what's the y. Well, guys, I can plug in the x to find the y. 2x plus y is equal to 3. They gave me the x. 2 times 3 plus y is equal to 3. So see, this is an easy one. I just need to find out what the y is when the x is 3. 6 plus y is equal to 3. Let's subtract our 6 from both sides. And y is -3. There's my answer. My solution would be 3, -3. They gave me the x. All I had to do was plug in the x to one of the equations and find the y. Okay. Now this says, which system of linear equations when graphed has lines that intersect at 5, 10? So in other words, 5, 10 is the solution. We want to know which system of equations is the solution for that. Okay. There's 2 ways I could go about this. Well, 3 ways actually. You could plot each one of these sets and see where they intersect. You could use substitution. Plug in the 5x for the y here. Or you can plug this point in and see which one it fits on. Okay. I'm going to just plug the point in and see where it fits. Let's see if it fits on this one. Y minus x is equal to 5. Here's my x, here's my y. Is 10 minus 5 equal 5? 5 is equal to 5, isn't it? So it works for this equation. Let's see if it works for this one. Because remember, it's got to be such that it's on both equations. Y is equal to 5x. Let's try that. Our y is 10. Our x is 5. Is 10 equal to 25? No, it's not, so it doesn't work for this equation. Although it fits in this equation, it's not on this one. So this is not a system where those two intersect. Let's try this one. Y is equal to 2x. Our y is 10. Our x is 5. 10 is equal to 10. Yes, it does work for this one. Let's try this one. X plus y is equal to 15. My x is 5. My y is 10. Is 15 equal to 15? It is. Guys, this is the equation for which it works because it fits in both of those. See how at the end of it, it says that these numbers are equal? It fits in both of those. Okay? Let's try another. Okay, now this one is kind of long. I'll go over it with you. It says, at what point in the coordinate plane do the lines defined by x plus y is equal to negative 1 and x minus y is equal to 2 intersect? Okay, so we're talking about two lines. We want to know where they intersect, okay? Give the exact coordinates, show your work, okay? Well, first, here is my system of equations. X plus y is equal to negative 1. X minus y is equal to 2. See, I put a bracket here. That tells me that's a system of equations, all right? Do either one of these say x is equal to? Okay, I could plot these, but I'm still going to have to solve for y. Why don't I solve one of these for x or y so I can substitute, okay? All right, so I'm going to come over here and try this. I'm going to say x plus y equals negative 1. And I'm going to rearrange this so it says y is equal to. I can do that by subtracting my x from both sides. And y is equal to negative x minus 1. I'll replace this with y is equal to negative x minus 1. Now I have a situation where I can substitute this in place of this y here, don't I? And this way we can find x. X minus, and what's our y? Negative x minus 1 equals 2. We know that there's an understood 1 in front of this parenthesis, so I've got x. Negative 1 times negative x is positive x. Negative 1 times negative 1 is 1 equals 2. Now, before I cross the equal sign, let's collect some like terms here. X plus x is 2x plus 1 equals 2. I'm crossing the equal sign, so I do the opposite of what's there. I'm going to subtract 1 from each side. 2x then is equal to 1. Let's divide both sides by 2, and x is 1/2. Okay, so I've got my x. Here on my point, I've got my x is 1/2. I need to find my y, because I'm looking for the coordinates where these intersect. Okay, now that we've got our x, let's find our y. Remember, we can plug it into either equation. Okay, so to find my y, what if I take this one? X plus y equals negative 1. Let's plug in our 1/2. 1/2 plus y equals negative 1. We're going to subtract 1/2 from each side. And y would be equal to negative 1 and 1/2. So my coordinates are 1, negative 1 and 1/2. Okay? Now let's try this one. Complete the sentences below by dragging and dropping the correct coordinate pairs into the boxes. Here are our choices. Our first set of coordinates, our first set here, and I'm going to put them down here so we can work on them, is 2x plus y. (2x plus y) equal negative 1. Negative x plus y equals 5. This is my set of coordinates. This is my system of equations here. To be able to solve that, I'm going to either have to plot these or I'm going to have to substitute one in, and neither one of these says x is equal to or y is equal to. But I can rearrange one of these, can't I? Let's take this first one. 2x plus y equals negative 1. And I'm going to make it say y is equal to. So I'm going to subtract 2x from both sides. Y is equal to negative 2x minus 1. Okay? So in place of this, we're going to put y is equal to negative 2x minus 1. To find our x, we will simply substitute this y in here. So I've got negative x, and in place of this y, I'm going to put negative 2x minus 1. okay, plus negative 2x minus 1. See, I put that in place of the y, equals 5. We have an understood 1 in front of this parenthesis, so I have negative x. Okay, 1 times negative 2x is negative 2x. 1 times negative 1 is negative 1. Let's collect like terms. Negative x minus 2x is negative 1x minus 2x is negative 3x minus 1 is equal to 5. I'm crossing my equal sign now. I'm going to add 1 to both sides. Negative 3x is equal to 6. Divide both sides by negative 3. And my x is equal to negative 2. Let's look at our choices. There's only one choice that has x is negative 2, so there's that one. Negative 2, 3. Okay? Now, let's look at this one right here. I'm going to erase what's there so we can work on this next one. Remember, we've already used that negative 2x and 3. And we need to find a value on one of these. Here are our two equations. I've got 6x plus y equals 19. And I've got x plus 5y is equal to 8. And I want the solution, which is where the two intersect. Remember, you can graph, you can substitute, you can plug in to see if things work. Neither one of these say x is equal to or y is equal to. All right? Let's try this one and let's rearrange it. 6x plus y equals 19. Let's subtract 6x from both sides. And I've got y is equal to negative 6x plus 19. In place of this, I'm going to put y is equal to negative 6x plus 19. See, I've rearranged it, so I've got y is equal to. I'm going to be able to plug this in for this y. So to find x, I would say x plus 5 times, and here's my y, negative 6x plus 19. See, I've substituted this in place of y, equals 8. X, and then 5 times negative 6y is negative 30. Negative 6x is negative 30x. 5 times 19, if you put that in your calculator, you're going to get 95. Let's collect like terms. 1x minus 30x gives me negative 29x. Plus 95 equals 8. Now we're going to cross the equal sign. I'm going to subtract 95 from each side. I have negative 29x, 29x is equal to negative 87. If I divide both of those by negative 29, I get x is equal to 3. There's only one of these that's got 3 for the x value. I could go ahead and continue to see if my y was right, but there's only one that has x as 3. Okay, let's look at the next one. The solution to a system of linear equations is 3, negative 5. That means that's where they intersect, right? Graph two lines that could represent this system of equations. So we're going to graph these. If I put the point at, what was the point? Let's see. It's 3, negative 5. Okay, so go out 3, 1, 2, 3, down 5, 1, 2, 3, 4, 5. I need to draw two lines here. I've drawn this one and this one. It doesn't matter if you draw any two lines, they just both have to go through this point. A system of equations is graphed on the coordinate grid below. What's the solution? Explain how you know. Well, we know it's a solution because it's where the two lines intersect. This is at 2, negative 2. Explain how you determine your answer. I found where the two lines intersect because where the two lines intersect is the solution. What's the solution to the system of equations? Explain how you found your answer. The solution is where the two lines intersect, which is at 3, 3. How do I know that? The solution is where the two lines intersect. A system of equations is graphed on the coordinate grid below. What is the solution? Explain why this is the solution. The solution is at -1, 2. I know that's the solution because it's where the two lines intersect. Which point is a solution to the system of equations below? Well, I could find the solution here simply by substituting, plugging this in place of that. Okay, if I do that, I've got 2x minus 2 is equal to x plus 2. I could solve for x. That means I subtract x on both sides. X minus 2 is equal to 2. Add 2 to both sides. X is 4. The only one that has 4 is x is this one. Or you could take that and plug each one of these answers into each one of these problems and see if they work. If you were dealing with 4, 6, you can plug it in. You've got 4, 6. This is your x. That's your y. Is 6 equal to 2 times 4 minus 2? Is 6 equal to 8 minus 2? Yes, it is. So for 4, 6, this one works. Is y equal to x plus 2? Let's see if this is a solution for that one. Is 6 equal to 4 plus 2? It is. Both of those are. So that would be the solution. You can do that either way. That's your choice. Okay? So look at this one. The following system of equations has no solution. When they're graphed, what does that mean? It means they're parallel. If lines are parallel, they have no solution. They do not cross, right? Look at the system of equations below. What points represents the solution to the system? Well, I can plug these in, each one of these in, or I can use substitution. If I look at what I've got here, I've got one that says y is equal to. I can plug this in for y. X plus 3 times my y, which is 3x minus 6, equals 12. See, we're trying to find our x here. Once we find our x, we're done because we only need to find one of those. There's no x's repeating. X plus 3 times 3x is 9x. 3 times -6 is -18. Okay? X plus 9x is 10x. Okay, let's add 18 to both sides. See, here's our line. 10x is equal to 30. Let's divide both sides by 10. And x is equal to 3. Now, where's the only one where x is 3? This one right here. Okay? And then let's look. Oh, wait, that was the last one, right? Yeah, okay. This is just simply a review for you. If you were looking at two linear equations, and they have the same slope, but different y-intercepts, then we're looking at a pair of parallel lines. If you're looking at two linear equations and they're exactly the same, then you're talking about two lines that are the same. They have infinite number of solutions. The parallels have no solutions. What if you're looking at an equation like this? The slopes are not the same. Okay, if the slopes are not the same, guys, then they're going to intersect somewhere, and you have got one solution. Okay, that covers the homework for this particular